This is Advanced Math, Unit 6, Lesson 4. Double angle formulas. Okay, for today, for this lesson, I'm only going to give you the formulas. I'm not going to explain the how and why behind it. We'll do that in class together. It is a little confusing on some of them, or it's lengthy to explain, and I'd rather do that in class. So for now, I'm just going to give them to you. You can accept them, use them, and we'll learn more about them in class. Okay, sine of 2 theta. B. Now we're working with sine of 2a, or sine of 2b, or sine, in this case, sine of 2 theta. It equals 2 sine theta cosine theta. That's the formula for sine of 2 theta. Cosine 2 theta equals cosine squared theta minus sine squared theta. And you can still think of sine being friendly, intermingling with the cosine, and cosine is still snobby. It's separated from the sine. The sine and cosine are separated. Okay, now because of our Pythagorean identities, we can rewrite these. The first one has no squared, so sine is sine and cosine is cosine. But we have our identities for sine squared and cosine squared that we can rewrite them. So I'm going to give you other possibilities that you will need to know. 1 minus 2 sine squared theta. That's if you were to rewrite cosine squared as 1 minus sine squared. And if you were to write sine squared as 1 minus cosine squared, you would get 2 cosine squared theta minus 1. Again, for now, let's just accept them. We're going to use them. We're going to know that these are the 3 possible ways to rewrite cosine 2 theta. And in class, I will explain more of the how and the why. All right, last one, tan of 2 theta equals 2 tan theta over 1 minus tan squared theta. All right, definite formulas you're going to want to add to your list of formulas that we've been working on. All right, examples. Simplify. Number 1, 2 sine 50 degrees times cosine of 50 degrees. Okay, so what we're doing is we're working backwards, or in other words, condensing is what we called it on the previous lessons. So 2 sine 50 cosine 50, which one does that look like here, and how can we get it to work backwards? So you can see that it matches this one here. 2 sine 50 cosine 50 is equivalent to the 2 sine theta cosine theta. Working backwards, it becomes sine of double the angle. Notice the 2 is gone, and it's sine of double the angle. So sine of double the angle, and you can only do this when these 2 angles are the same, which they are, 50 and 50. If they were not, we would not be able to use this formula. So sine of 2 times 50 degrees, which equals sine of 100. Now, because 100 is not a special angle, we're not going to evaluate it. We're going to leave it like that. That is the answer. Number 2. Cosine squared 7 degrees minus sine squared 7 degrees. I'm going to call this 2a. Okay, which one does this look like? Cosine squared minus sine squared. It's right there. Do you see it? So when it condenses, it becomes cosine of double the angle. The squares are gone, and it's cosine of double the angle as long as those 2 angles are the same. Cosine of 2 times 7 degrees is cosine of 14 degrees. And again, that's not a special angle, so we're going to leave it like that. Okay, 2b. Cosine squared 25 degrees plus sine squared 25 degrees. Okay, where kids mess up on this one on the test is they try to force this one to look like this, but can you see that this one is minus and this one is plus? Kids will say, oh, well, it's the opposite because it's flipped around. No, it's not. That's minus, that's plus. Cosine squared stayed positive, and we only took the opposite, excuse me, of the sine squared. So it's not anything to do with these formulas here at all. Hoping you recognize it as one of our original Pythagorean identities. And when you have sine squared plus cosine squared, it comes out to be just 1. Not negative 1. It doesn't matter that these two guys are flipped because they're flipped on an addition sign, and addition is commutative. So it's not negative 1, it is just 1. And again, that's using our old original Pythagorean identity. Okay, number 3, 2 cosine squared 40 degrees minus 1. Now that's not a Pythagorean identity, that's right here, the double angle. Do you see it? 2 cosine squared theta minus 1, where theta is 40. So it becomes cosine of double the angle. The 2's gone, the squared's gone. It's cosine of double the angle, so cosine of 80 degrees is our answer. Okay, number 4. 2 sine squared 35 degrees minus 1. Okay, so this one is also not a Pythagorean's identity. It's one of these here. It looks closest to this one. There's the 2 sine squared theta. There's the 1. The only thing is it's flipped, and it's not flipped on a positive sign. It's flipped on a negative sign. And subtraction is not commutative. What happens when you flip on the negative? It's the opposite. So it's going to be the opposite of cosine double the angle. Again, the squared's gone, the 2 is gone, it just becomes cosine of double the angle. In this case, the opposite because it's flipped on the negative. So the opposite of cosine of 70 degrees. A common mistake kids make is they'll say, oh, but cosine absorbs the negative, which is true. It absorbs the negative here. Cosine of a negative is gone. It's just cosine of that number. But when the negative's already out front, it does not absorb the negatives that are out front, only the ones that are here. Make sense? Again, cosine only absorbs, like if it was cosine of negative 70, I can rewrite it as cosine of 70. Negative cosine 70 is negative cosine 70. It does not absorb. Okay, number 5. I'm actually going to put number 5 on the back only because I want to compare it to 6 and 7. Okay, 5 is 2 tan 100 degrees over 1 minus tan squared of 100 degrees. Okay, so flipping back over really quick, you could see your tangent formula. I'm going to rewrite it here just so I can put it on the other page. Tan of 2 theta equals 2 tan theta over 1 minus tangent squared theta. Okay, so I'm just rewriting it so I can compare it to this side here, and sure enough, that looks the same. There's the 2 tan theta, 1 minus tangent squared theta, so it equals tangent of double the angle, and our angle here is 100 degrees. So that's going to become tangent of double the angle. So tangent of 200 degrees is what we end up with. And again, 200 is not a special angle, so we're not going to evaluate. Number 6. 1 minus tan squared 20 degrees over 2 tan 20 degrees. Okay, so we can tell that it's the tangent function, but how is it different? Can you see the difference between these two? What happened? Did it flip on a negative or did it flip on the fraction? And you do need to know the difference for the test. Can you see that it's flipped on the fraction? The 2 tan theta is in the denominator, and the 1 minus tan squared theta is in the numerator. So it flipped, which means reciprocal. I'm going to write that up here. And what is the reciprocal of tangent? Cotangent. So it's cotangent of double the angle, and you will need to know that for the test. Okay, so this is regular, this one is reciprocal, and the reciprocal of tangent is cotangent. So cotangent of 40 degrees is what we end up with. Okay, let's try another one like that. Number 7, 2 tan 35 degrees over tan squared 35 degrees minus 1. Okay, what is going on here, and how is that similar or different from this one here? Okay, so we can see again it's still the tangent formula, and the 2 tan thetas at the top, and what's at the bottom is at the bottom, but it's flipped on the negative. Do you see that? Tan squared comes first, the minus 1 comes second. So is it the reciprocal? No, it is the opposite. I'm going to write that up here, opposite. So what you have to be able to do on the test is recognize, first off, that these are all tangent type functions. Notice when it's the reciprocal of the tangent function and when it is the opposite of the tangent function. And the opposite of tangent is just negative tangent of double the angle, 2 times 35 degrees. So negative tangent, 70 degrees. Regular, reciprocal, opposite, and know how to recognize all of those. Okay, number 8, 1 plus tangent squared of 18 degrees. Now, you may be looking at that and being like, what is that? It doesn't look like any of our formulas that we have here at all, and it's not. 1 plus tangent squared of 18 is an old Pythagorean's identity that we learned last unit. And as I told you last unit, those formulas that we learned then we're still going to use on this test as well. So you do still have to memorize what 1 plus tangent squared is. And 1 plus tangent squared is secant squared, not secant double the angle, secant squared 18 degrees. Sometimes because they'll say, oh, it's secant, and they get so used to doubling, they do that. Secant of double the angle. Please do not make that mistake. It's not secant of double the angle. It's just regular secant squared, just like what we've done in a previous unit. Okay, number 9, 2 cosine squared of 150 degrees. Take away 2 sine squared of 150 degrees. Okay, that doesn't look like anything. Well, it looks close to this one, but the one that I just wrote down has 2's as a coefficient and this one does not, so maybe we can GCF it. Take out a 2, leaving me with cosine squared 150 minus sine squared 150. Now, because it's the minus, is this the Pythagorean identity? No, it's not. This is the double angle identity, so that 2 still on the outside. And then when I change this, it condenses down to cosine of double the angle. Cosine of double the angle. Cosine of double 150 degrees. So then I have 2 times cosine of 300. And 300 degrees is a special angle. It's 60 degrees in quadrant 4. And in quadrant 4, cosine is positive. So cosine of 300 is 1/2. So I have 2 times 1/2 equals 1. Again, this is 1/2. Cosine of 300 is 1/2. 2 times 1/2 is 1. 1 is your final answer. Okay, and number 10, verify the ones where we prove we work with one side only. Okay, cosine of x plus y plus cosine of x minus y equals 2 cosine x cosine y. All right, so this is the one where we pick a side, we work with that side only, we'll manipulate it to look like the other side. Okay, I'm going to pick the left side because I can see here that I can use some formulas. So this is the side I'm going to bubble in. And the formulas I'm going to use are not the formulas we just learned today, because the ones we just learned today are like 2a, 2b, or 2 theta, where this is like a plus b, a minus b. These are the ones that we learned in the previous lessons, the angle addition laws. So remember, cosine snobby. So I'm going to expand the first one. I will use colored pens. I'm going to expand this one to cosine x cosine y, opposite sign for cosine, minus sine x sine y. All right, next one, because it's a plus sign, I don't have to worry about distributing anything. I can just write plus, and then again expand cosine x cosine y. Opposite sign is now plus sine x sine y. And we do have some like terms. It looks like this one right here is going to cross out. Can you see that? Sine x, negative sine x sine y, and positive sine x sine y cross out. And then I have positive cosine xy and positive cosine xy, which is 2 cosine x cosine y equals 2 cosine x cosine y. And that is it for this lesson.